On this video, we're going to learn how to graph rational functions. So to graph a rational function, first we have to identify the asymptotes. Okay, so we have vertical asymptotes and we have horizontal asymptotes. So a rational function in simplest form has a vertical asymptote at the zeros of the denominator. And you can think of this as, remember, we can't make the denominator 0 because that's it's undefined when we divide by 0. So that's why we have this kind of limit line at the zeros of the denominator. A horizontal asymptote, so this one's a little different. So a rational function has at most one horizontal asymptote. To find the horizontal asymptote, if any, we compare the degree n of the numerator with the degree m of the denominator. And remember, the degree is the highest exponent in either the numerator or the denominator. So we look at them kind of separately. So we use n as the numerator and m as the denominator when we're comparing here. So if the numerator is less than the denominator, remember I'm talking about the degree here, then we have a horizontal asymptote at 0. If they're equal, if the degrees are equal, then we have to compare them, and we have to create a little fraction here. We use the leading coefficient of the numerator divided by the leading coefficient of the denominator. And the leading coefficient, remember, that's just the number. Once we identify the degree, the highest exponent, the leading coefficient is just the number in front of the variable there. So it's the number attached to the front of the highest degree. So you create a little fraction, and then if the numerator is less than the denominator, then there is no horizontal asymptote. Okay, so to graph, you start by drawing the vertical and horizontal asymptotes, because that shows you your limits. That gives you your areas to graph. Then you plot 2 points on each piece of the graph. What this means is you graph 2 points to the left of the vertical asymptote and 2 points to the right of the vertical asymptote. Okay, so it's going to look like there's 4 sections of the graph, but really you're focusing on the vertical. Okay, and finally you click on Graph a Function button when you're on ALEKS. If you're doing this on paper, you're going to kind of eyeball the graph a little bit more, but on ALEKS it will actually graph it for you once you have your pieces. So remember, think of the asymptote as a limit line, that the function is always approaching, but it's never actually going to reach. It's just getting closer and closer and closer to these limit lines. Okay, so we have Gandalf here, and he's saying, "You shall not pass." If you've never seen The Lord of the Rings, I'm a little sad, but this is just a funny little thing to remember. You know, it's just this line that he's standing there going, "You shall not pass." Yes, this has a whole lot to do with Lord of the Rings, because Balrog is the monster that he fights, and he's in the Mines of Moria when he fights him. So there's, all kinds of silly little references here, but just kind of keep that in mind. It's a line that is not passed by the graphed function. Okay? All right, so let's go ahead and practice this. Oops, that did not animate correctly. That's okay. I'll fix that later. So here is our rational function. And rational function, if you don't remember, it's a fraction. Okay? So it's when we have two expressions and they're in a ratio, okay, in a fraction. So if you find the x and y intercepts first, if they exist, then you can find the other points. That's a little easier. And if you notice, I kind of already set it up for this. So this is not going to be a table that Alex is going to give you, but this makes it a little easier if you find the x and y intercepts first. So before we do that, let's go ahead and find the vertical and the horizontal asymptote. So the vertical asymptote, we're going to take that denominator, negative x minus 2, and we're going to set it equal to 0, and we're going to solve. So I'm going to add 2 to both sides, because I want to get x by itself. I have negative x equals 2, but remember, I don't want to know what negative x is, so I'm going to move that negative to the other side, so I have x equals negative 2, and here is my first asymptote. So this is my vertical. Okay, now for the horizontal, I need to look at the degrees. So I have the degree of the numerator is 1, because there's an x here, and if I don't see the exponent, then it's a 1. I also have a degree of 1 here. So they are equal to each other. So in this case, I have to look at the leading coefficient, which is 2 and negative 1, and I have to create a fraction. So 2 divided by negative 1 is negative 2. So there is my horizontal asymptote. So I have my 2 figured out there. So now we're going to go through and we're going to find those x and y intercepts, just to kind of give us a simple way to kind of start here. Just because they're a little easier to apply a 0. All right. So if I apply 0 for x, then I'm going to put 0 in here for my formula. So 2 times 0 plus 3, and at the bottom negative 0 minus 2. Well, this becomes 0, and this also becomes 0 because negative 0 doesn't mean anything. So I just end up with 3 over negative 2. So 3 over negative 2. And then my next one, if I find the y-intercept, sorry, I'm finding the x-intercept on this one. This was the y-intercept. So if I find the x-intercept, I make y 0. So you can see I have 0 equals 2x plus 3. I really don't have to worry about the bottom of the graph when I'm finding the x-intercept. I can just focus on the top of the graph. Okay, so that's why I don't have the full fraction. I'm just focusing on the numerator. So I have negative 3 equals 2x, and I'm going to divide by 2 on both sides. So I end up with negative 3 over 2. So I have 2 spots, and you can see I've graphed them here. Okay, so there are 2 points on the right side of the vertical asymptote. So both of these ended up on the right side, right, of the red line. So I need 2 points on the left side. And the easiest 2 points to grab are just the next 2 points, negative 3 and negative 4. Okay, so now we're going to plug negative 3 in here. And you can kind of already see this was filled in beforehand. So 2 times negative 3 is negative 6 plus 3. Negative 3 is positive 3 minus 2. So negative 6 plus 3, that gets me negative 3. And 3 minus 2 is 1, which is really just negative 3, right? So it's negative 3, negative 3. And then we'll plug in negative 4 here. So I have 2 times negative 4 plus 3, negative 4 minus 2. So I get negative 8 here because 2 times negative 4 plus 3. And then negative 4 is positive 4 minus 2. So I end up with negative 5 when I subtract across the top and positive 2 on the bottom. So now if I graph those 2 points, now I have them on the left side. And when I click the graph a function feature, I'm pretty sure that's what it's called on there, it will automatically graph this for me. Now if it's crossing one of your asymptotes, you need to go back and make sure, number one, those are in the correct place, that you didn't accidentally kind of calculate those wrong. And then you also need to make sure, go back and check your math on your points, because you need 2 points on the right, 2 points on the left. And if they're not quite lined up correctly, if you accidentally did it a little wrong, it's going to graph it a little funny. So you need to make sure that all of your math is, kind of spot on there. I know that sounds very picky of me, but Alex will graph it incorrectly if either the asymptotes are in the wrong spot or if you have not graphed 2 points on each side correctly. So just be careful about that, but that is how you graph a rational function. I hope that helped, and I will see you in the next video.